I've started the recording, so I will just take this particular flowchart, okay, and we will take examples as a digit here, and we will simply follow this flowchart step by step, and we will continue. So this will be our task. Okay, it will be not very difficult one. It will be very easy because you can completely see the overall flowchart steps, what are actually happened one by one, and then you are just following them. Okay, so let me just copy all this slide with this flowchart only. Thus we can continue later very fast. So let us first start with this section. Uh, 1 minute. Draw pen. Yes. So let us first start with this add operation. Okay. So if you consider in this add operation, you have two numbers. It is already, we have seen this on the last day, A and B, agent and addend, right? Now what may be the combinations of the number, right? So if you are taking two similar sign bit number, that means AS XOR BS, when will provide the 0. In that case, there may be two options. What kind of options? You have taken positive A, positive B, or you have taken negative A, negative B, right? So we will consider these two cases first. Okay, then in another cases, what you can consider that the different sign. So that means either it may be negative A, positive B, or the different or the opposite one, positive A, negative B, whatever may be, and we will follow this pattern. Okay, so this type of one more example we will consider. So let us first start with the easiest one. That means both the positive number we have and we are performing the addition. Okay, so no need to do any extra other thing. Just follow the steps. You will finally get your result. No need to do any extra step. Okay, so let us consider the first example. Say you have taken the number 3-bit number you can consider, or any type. Let us consider that we are performing this addition within 4-bit. Okay, so according to this, what should be your structure? Now this register will have 4-bit. This register also will have 4-bit. This will be your adder. I am not including the complementer, that is also coming with it. So from here one number is coming, from here one number is going, and the result is coming into that register. So result is also of how many bit? 4-bit. Along with them the E is there, the ABF is there, all are there, no problem. But we are considering only 4-bit addition. Okay. So now think when you will do this, just like say what the number I can take. You can take the number like +6 and +7. So say your A is +6, B is +7. So what should be your AS in that case? Obviously 0. What should be your BS in that case? Obviously 0. Any confusion? I hope no. So what you will write in case of A? A will be 0, 1, 1, 0, and B will be 0, 1, 1, 1. Is it fine? I hope so. So you have now stored your A, you have now stored your B. How you have stored? In your A it is 0, 1, 1, 0. In your B it is 0 followed by 1, 1, 1. Now what the next step? Next step is, why I have started from this operation? Because we have started with this addition operation initially. It has been informed that you are going to perform a addition operation. That is why you are starting from this zone. If you are asked that you should perform one subtraction operation, then you should start with this section. Okay, so as I have already mentioned that I am starting the addition operation, that is why from here it is being started. Okay, so next one is addendum A, addendum B. I have stored A and B as 0, 1, 1, 0 and B is 0, 1, 1, 1 respectively. Next one is AS XOR BS. So what is this AS XOR BS? What is your AS basically? Your AS is 0, your BS is also 0. So now perform the AS XOR BS. What should be the result? 0 XOR 0, that means the result is also 0. So you are coming from this zone. AS equals to BS. You can see your AS equals to BS equals to 0. So now next what to do? Simply we'll perform EA is equals to A plus B. So what is your EA should be now? It is A plus B, which should be actually 0 followed by 2, 1, then 0, and B is 0 followed by 3, 1. Now add it. 1, 0, 1, 1. Right? Now what you are storing here? A and B you have added. So in A, the result will be stored, and in E, the carry will be stored. So right now, is there any carry generated? It is a simply no, right? So that means E is 0 and A is this one, 1, 1, 0, 1. What is my next step? E should be transferred to AVF. So that means your add overflow flag register also represents a 0. That means there is no overflow, right? And finally, what you are doing? You are simply passing this data to here. From here, you can see directly there is nothing in between it. Okay, it is completely just an arrow. Okay, so that means finally from where you can get your result in A and AS. So what was your A after all this operation? It is 1, 1, 0, 1, and what is your AS? It is 0, because initially your AS was 0, and you can see from those steps nowhere your AS had been modified, right? That is why your AS is also 0. So finally, this is your result. And if you check, it is plus 6, it is plus 7, that means plus 13. So it is 1, 1, 0, 1, 8 plus 4 plus 1. So that means plus 13. 0 represents plus. So we have completed the first example. Okay. I hope that everyone got it, that how this addition is being happened. If any step, any problem, you can repeatedly ask. You can again ask me to repeat. So this is the ideal case or minimum steps, because there is no new thing you are doing. You are simply storing AS and BS. You are observing that it is actually a case of all the addition, all the positive number addition. So simply we'll perform the addition and simply we'll get the result. Done. Right. So next one, when you will do, let's say again the same example of uh, addition again. Two numbers has been given as -6 and -7. So it represents your AS should be 1, A should be 0, 1, 1, 0, your BS is 1, your B should be 0, 1, 1, 1, right? -6 and -7. sign bit, both the sign bit is 1. So again you will perform the XOR operation. What you will get as a result? 1 XOR 1 means 0. So again it will follow the same route. EA equals to A plus B. Now think that you don't need to change anywhere, you don't need to do anything. It is asking to perform simply addition, so you will simply perform these two addition. E is equals to A plus B, right? So EA A plus B, how? It is 0 1 1 0, it is 0 1 1 1. So that means finally your result should be 1 1 0 1 13, and your result has been accommodated in 4-bit just like the previous case. So if you transfer this E to ABF, it will imply that your ABF is also 0 because no carry has been generated. So finally your result should be from AS and A. So what was your AS initially? You can check your AS was initially 1, and throughout the steps nowhere we have changed AS. So AS is still 1. That means your AS is 1 and your A is 1 1 0 1. So now if you overall comparing or overall considering that what is your result? So this one represents the negative number and this is 13. So minus 6 minus 7, if you add, what should be the result? It is minus 13. And that's the final answer. Minus 13. Okay. So two cases of addition we have discussed till now. Right? If you go again to the previous one, this cases also has been discussed and this cases also has been discussed. Now what need to do? Now we will check different sign and addition operation. Right? So let's take another example. This is our example 3. Now think that your A is, what I can say, your A is minus 9 and your B is plus 5, you can write. You are going to addition and this is what addition? It is 4-bit addition. So how you will represent this A? AS is 1 and A is 1 0 0 1. How we will represent B? BS is 0 and B is 0 1 0 1. Right? Now what you will do? You have already stored A and B. Next task is to perform the XOR operation. So you are performing XOR between AS and BS. So now if you perform the XOR, it will return a 1. 1 XOR 0 is 1. That means different sign. So we will come which step? We will come directly from here to here in this zone. So now what you need to do? You need to do now EA is A plus B complement plus 1. See, I am just following the flowchart or algorithm. EA is equals to A plus B complement plus 1. So that means if your B is 0 1 0 1, what should be your B complement? It should be 1 0 1 0. And B complement plus 1 means along with this another 1 will be added. Okay. So now what we will do? What was our A? Our A was 1 0 0 1 and B complement was 1 0 1 0. So if you add 1, then it will be 1 0 1 1. So just add it. You have added B complement plus 1, you got This one is b complement plus 1. This is a. So now what should be the result? It is 0, it is 0, it is 1, it is 0, it is 1. Right? So then what should be done? You have got A is equals to 1001, B equals to 0101, right? BS equals to 0. So this thing has been done in this step. This 0 has been given in this step. 9 has been given in this step. Negative sign has been given in this step. You have performed AS XOR BS. It got a 1. So it will perform this negative operation. It has come in this step. You have taken A plus B complement plus 1. It is 0101. It has been complemented. It is 1010 followed by 1. Okay. Then what we are observing, that you have performed this thing also, 0 1 1 0 1 0 0, right? This one, this whole. Now you can see your E is 1 because you are storing it into EA. So your A will store 0100 and your E will store a 1 simply, right? So you are getting a 1 here. Your A is right now not equals to 0. You can see it is 0100. That means A is not equals to 0. So simply you will come in this side and your result will come in here. Simply you will follow this route. So right now your result is 0100 and your sign bit should be taken from A. Your sign bit was initially 1, this one, and in this route if you see nowhere your AS has been changed. So that means your final result should be AS is equals to 1 and A is equals to 0100. So overall if you write, it is actually -4. Correct? I think no confusion. So I am, if you just give me a green signal, then I can go to this operation now. 3 example has been discussed for this example, this operation: positive positive, negative negative, positive negative. Okay, now we should consider the subtraction also, and we should discuss some of the subtraction example. So can I go to subtraction, or you can have some further questions or some further doubts? See, already on the last day one example slide with 6 to 7 problems has been uploaded in YouTube, and there will be also 6 to 7 problems will be there in this page. So almost 14 to 15, 12 to 14 problems you will have in your YouTube study mates YouTube video. So if you get them, then you will more familiar with it if you do one more example or two more example. So should I go to subtraction operation now, or I have to give another example of addition, or any doubts what I am discussing till now? Anything, please, just anyone, if of you some response. So no response, then I can directly move to subtraction. Okay, all are silent. That means I will expect that yes, that is a positive signal. Okay, so now we are going to the subtraction operation. Okay, so if you go to the next slide, we will take now this operation. We will again consider the same thing like subtract. Again, it will be 4-bit. Okay, so now when you will just store them, similarly minuend and subtrahend, so once will be stored in A, one will be stored in B, whatever may be. So just consider again the 3 cases. Signs are equal, signs are different. Equal sign, no problem about the which is bigger, which is higher, which is lower, and same sign maybe we can discuss that which sign is higher, which sign is lower. So all these things can be discussed, right? So let us first take some simple example that you are considering the subtraction of plus 5 minus 9. This subtraction we are considering. Okay. So what should be done first? Your A is, this is your A and this is your B. Your A is basically now 0. Your A is now 0, 1, 0, 1. Your B is now a 1 and your B is now as 1, 0, 0, 1. So if you perform the XOR operation now, first we will do this AS XOR BS. So it will give you 0 XOR 1. So that is actually 1. Okay. So I have started from this zone. I am coming into here. I have stored the data into A and B. I have performed the XOR operation. I got a 1. So where should I go? I should go in this zone. Right, and in this zone means you will simply perform the addition between A and B. So what was your A? Your A is 0, 1, 0, 1. Your B is 1, 0, 0, 1. So you will simply perform the addition between A and B. So how it will be performed? A will store the addition result of A and B, and that should be 0, 1, 0, 1 plus 1, 0, 0, 1. It should be 1, 1, 1, 0, right? So that means your A is holding a 0, your your E is holding a 0 and your A is holding 111, 0. So this E should be transferred to ABF, so that means ABF is also 0, so no overflow. So that means finally your result should be from AS and A. So in AS what the sign was stored, it was 0. So finally you will write your AS is 0, your A is 111, 0. Now if you just do it manually, plus 5 minus 9. Actually you are doing this 5 minus 9. So it is clearly 5 plus 9, 14. So final result is plus 14. Right, so we have started from this zone, we have seen that separate sign and we have come into this zone and we have done our operation. Now think, if you are given this thing, instead of giving this plus 5 minus 9, if they are opposite, just like if you are being asked to perform minus 9 minus plus 5, then what should be done? It should be just A will store 9 and B will store 5. So we can also check this thing gradually, right? So let us consider this example now. This thing we have done already. We will move to the next slide and we are in the same position again, just like we are performing a subtraction, right? Only the separation difference is right now your A is storing minus 9 and B is storing plus 5. So that means your AS is 1, your A is 1001, your BS is 0, your B is 0101. Now when you will perform this thing like again AS XOR BS, it will again give you the result as 1. So that means you are again going to this addition zone, right? So that means simply we will again perform the addition operation. EA will store A plus B and your A is 1001, your B is 0101. So the result will be triple one zero. EA is storing triple one zero. That means in A you will have this value triple one zero, and in AS what should be stored in AS? AS has not been changed, so AS will be still the one. E will be 0. Similarly, A is also 0. So now your result is AS is equals to 1 and A equals to triple one 0. This will be your result. Now what is this actually? AS1 means negative and triple one 0 means 8 plus 4 plus 2, 14. So it is minus 14. If you perform this operation minus 9 minus plus 5 just like this, what should be the value? The value is minus 14. Okay. So any confusion or any clarification or any other thing? I'll be happy to get some confusion. No confusion, then I'll go to the next problem. Okay, so for subtraction, two examples we have considered separate sign. One number is higher than other, and that positions also has been changed. So one time we have checked that this thing gave us the positive result, and another time we saw that this thing gave us the negative result. So now we will move to the next part, that is the subtraction again with different sign. Sorry, with different sign we have done. So subtraction again with same sign. So let us consider again some example. Just like you can consider minus 7 minus, we are performing subtraction, that is why this negative. This is the sign bit of this 7 and this is the sign bit of this number, this thing, minus 7 minus minus 6. So that means your AS is 1, your A is 0 followed by triple one, your BS is 1 again, your B is followed by 0 double 1 0. So now you are getting that your AS equals to BS. AS equals to BS, XOR will throw a 0 output. So AS XOR BS will give you a 0 output. So that 0 is representing that you have to come in this zone only. So in this zone, what is happened or what is waiting for you? It is A plus B complement plus 1. So that means it is A plus B complement plus 1. That thing will be stored in EA. So if you do this thing, A plus B complement plus 1, what was my B? My B was 0 1 1 0. So now it should be 1 0 0 1. Along with you will add 1. So your final result will be 1 0 1 0. Right? This is B. This is B complement. This is B complement plus 1. So now it should be added with A, and what was my A? It is 0 followed by triple one. So you can simply write. Now just add them. It is 1. It is 0 1 1 0. It is also 1 1 0. It is also 1 1 0, like this. Okay. So this is being stored into your EA. Right now we are in which section? Right now we are in this section, right? So we will check whether your E is 0 or E is 1. So your A can store only 4 bits. So that means A is storing 0 0 0 1 and your E is storing a 1. That is why you can say that this a not equals to 0. Right now a is 1, so that means a is not equals to 0, so that means you can directly jump to your result, right? So that means what should be your result? Your a is 0 0 0 1 and your as is, what was initially as? It was this 1, that means is 1 again. Okay, so that is actually the result, -1. You can see -7 minus 6, it should throw you the result of -1. So this is your result, and this is the case when you are performing subtraction operation within two similar signed number. We have also checked whenever you will perform subtraction operation with both the different sign numbers, and what has happened, this example has been considered just before this problem. So I think one last problem should be calculated or should be considered. That is again the subtraction. But subtraction for subtraction of higher number from a lower number, this kind of thing. So say you have taken the number as 4 plus 4 in A. This should be AS is equals to 0 and A is equals to 0 1 0 0, right? Now think that your second number is plus 9. This should be this should be B. So BS will be 0 and B will be 1 0 0 1 9. Okay, so now what you will do? You will perform the same, just like this addition. This one and this one XOR. So AS XOR BS will give you the result as 0 XOR 0 means 0 simply. So that means you will come again in this zone. That means finally what you will do, you will perform A equals to A plus A complement plus B. So which should be a B complement? B is 1 0 0 1. So that means B complement will be 0 1 1 0. Okay, and 0 1 1 0 means plus 1 means 0 followed by 1 1. So A was your 0 1 0 0, and here you are basically adding with it 0 followed by 1 1. You can add it. It is 1 1. It is 0. It is 1. Right? What we got? 1 0 1 1. So that means A will hold 1 0 1 1 and E will hold a 0 because it is 4-bit addition result. Now check in your flowchart, if your E is 0, then what is happening? Your E is 0 means it is basically subtraction of lower number, subtraction of higher number from a lower number. Okay, so at that time your result is also complemented result. You have to take again one more complement of that result. So that means this data should be complemented again. That means this data you should calculate as A complement first. A complement will be just like 0 1 0 0. Now you add 1 with them because you have to perform A complement plus 1, right? So that means it should be 1. So that means it is 0 1 0 1. And this is your final A complement plus 1 actually. I can write it here, or later you can say face problem. So A complement plus 1. So that means this step you have done. Now the last step, AS should be the complemented sign of AS. Initially your AS was what? 0, right? It is being asked that AS should be complemented. So that means you should write AS as 1 complemented. So now what should be your result? In your AS there is a 1 and in your A there is 0, 1, 0, 1. It is actually 5 and it is actually the negative sign, that means negative 5. So you can consider that if you write 4 minus 9, you can simply answer this minus 5. So this was another example. Okay. Now anyone has any confusion, any clarification? Or any other example is coming in your mind? What the cases we have considered now? Till now, positive, positive in case of addition, negative, negative in case of addition, positive, negative in case of addition. Then in case of subtraction, again positive, negative. In case of subtraction, negative, positive. One example we should consider last, that is the equal sign or equal, not equal sign, equal number when the result will be 0. That last example should be considered. Okay, so let us take to one example where obviously you are performing subtraction. Okay. Now you will just think your A is plus 6, B is also plus 6. You are going to perform subtraction 4 bit. Okay, so that means again sign bit should be compared. AS is equals to 0, BS is equals to 0. So when 0 XOR 0, so that means it is coming into this zone. EA equals to A plus complement plus B, A plus B complement plus 1. Sorry, EA is equals to A plus B complement plus 1. So that means it should be A is your 0, 1, 1, 0, B was your 0, 1, 1, 0. So that means it should be 1, 0, 0, 1 and along with it is 1. So result will be just like 1, 1, 0 with a carry 1. This carry 1, that means it will be again 1, 1, 0 with a carry 1, that means again 1, 1, 0 with a carry 1, then again 1, 1, 0, it is 1. So you are getting your A as 0, 0, 0, 0 and E as 1, just this one, and your A is 0, that means you are coming into this zone basically, right? So once you are getting your A is 0, one more step you have to follow, that whatever initially this sign bit of A was, you have to finally put a 0 into this sign bit, because 0 is never negative. Again the same thing. So you will just again follow the next step, that is AS should be included in 0 and this is your final result. AS is equals to 0 and A is also 0, 0, 0. This is the overall example. So it is a subtraction when two equal numbers are being subtracted. So if you do the same thing in case of minus 6, the same thing will be happened, only instead of just like if you do it minus sign, so only instead of last AS initially was 1 and once you will do this thing, AS value will be updated from 1 to 0 and finally again you will have 0 followed by 4-bit 0. This is the final answer. Okay. So I have discussed today, I think 8 problems. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So I have discussed today 8 problems. So recording also I will upload within 15 minutes or 20 minutes or half an hour or maybe within 2 days. A simple word, within 2 days. Okay, and you can just practice. Next day, I hope that I can start the multiplication. Okay.